Good morning to all. In the last video, we are discussing about the relations and the types of relations and some examples also. Today, I will go some more example on the types of relations. Look at here. Show that the relations are defined in the set A of all the triangles as relation defined in such a way that set of ordered pair T1, T2 such that T1 is similar to T2 is equivalence relation. We have to show this relation is equivalence relation. And also consider three right angle triangle T1 with the sides 3, 4, 5, T2 with the sides 5, 12, 13 and T3 with the sides 6, 8, 10. Which triangle among these three are related? We have to show. Okay. Now first I will come to the whether this relation is equivalence or not. This relation is said to be equivalent. This must be satisfy the three relations, which are those reflexive, symmetric, transitive. First I will check reflexive, whether it is satisfying the reflexive or not. Now I will take any one of the triangle in the set of triangle. Any one triangle, that is I will take as an A, B, C. That is I will side 4, 5, 6. Now same triangle I will draw. Same side, same angle, everything is same. Now this triangle I wrote the same triangle only. Everything is same. These two triangles are the what? Congruent triangle. All the congruent triangles are similar triangles. We can go to the definition also. The corresponding sides are proportion. 4 by 4, 1, 5 by 5, 1. Like that also we can verify that these two triangles are similar triangle. Hence what we can say that all the triangles are similar to itself. Then given relation is an reflexive relation. What we can give the conclusion? All the triangles are similar to itself. Similar to itself. What we can say? T1, T1 is belongs to relation. T1, T1 is belongs to R means what we can? R is reflexive. R is reflexive. Next one. What is the next one? Whether this relation is symmetric or not, we have to show. Now I will take in one of the ordered pair T1. If T1, T2 is belongs to R. It is belongs to R means what is the condition they given? T1 must be similar to T2. Okay. Now T1 is similar to T2 means can we say T2 also similar to T1? Yes, let me see. This is an A, B, C, 4, 5, 6. This is an somewhat. Okay. Yeah. D, E, F. 12. Now these two are the similar triangles. A, B, C similar to because corresponding sides are proportion 4 by 8 is the 1 by 2, 5 by 10, 6 by 12. Now I will take a reverse of the corresponding sides in the reverse. That is an 8 by 4, 2, 10 by 5. Then corresponding sides are proportion. If you take a reverse also, then what we can conclusion? T2 it implies T2 also similar to T1. T2 also similar to T1 means T2, T1 is belongs to where? Relation R. If nothing but then this T2, T1 is belongs to R means what we can conclude? R is symmetric relation. R is symmetric relation. Now R is reflexive, R is symmetric, one more is R is whether transitive or not, we have to check it. Okay. Now let me see. Now we will take a two ordered pair. If T1, T2 is belongs to R, I will take it, and also one more ordered pair T2, T3 is it in the R. Both ordered pair it is the relation means what is the condition for that one? T1 is similar to T2 and T2 similar to T3. Such a way that they given the definition of the relation. Now T1 is similar to T2 and T2 is similar to T3. Can we say T1 is similar to T3? For example, let us take A, B, C, 3, 4, 5, and I will take D, E, F, 6, 8, 10. Then one more triangle I will take M, N, O. That is a now this is similar to this, corresponding sides are proportion 1 by 2 you will get. This is also similar, corresponding sides are 1 by 2 you will get. Now this is similar to this one, this is similar to this one. Can we say this is similar to this one? Let me take a corresponding 3 by 12, how much will come? 1 by 4. Then 4 by 16, 1 by 4. 5 by 20, 1 by 4. Then what we can give the conclusion? T1 is similar to T3. T1 it implies T1 is similar to T3. Now T1 is similar to T3 means T1 comma T3 is belongs to R. Now T1 comma T2 is in the R, T2 comma T3 is in the R. It implies T1 comma T3 is in the R means what we can give the conclusion. Therefore R is transitive relation. R is transitive relation. Now relation is an reflexive, symmetric, transitive. That relation is satisfying the three relation also. Then what we can give the conclusion? Hence R is an equivalence relation because it is satisfying the three relations also. Okay, understood? Now let me come to the second part of the example. What is the second part? Consider the three triangles. Which are those? T1 with the sides 3, 4, 5 and T2 with the sides how much? 5, 12, 13. T3 with the sides 6, 8, 10. Now T1 they given how much? Very okay. 3, 4, 5 and T2 with the sides 5, 12, 13 and T3 with the sides 6, 8, 10. Which among these two are the related to each other? Which among these two are the similar triangle? We have to show. Now I will take a proportion of the corresponding side. 3 by 5, okay, 3 by it will not come. 4 by 12, that is 1 by 3 it will come. 1 by 3 it will come. Then corresponding sides are not a proportion. Hence there is no related between these two. Let me check these two. 3 by 6, what will come? 1 by 2. 4 by 8, 1 by 2. 5 by 10, 1 by 2. Then corresponding sides are what? Proportion. Then what we can say? T1 is related to T3. T1 is similar to T3. Nothing but T1 is related to T3. Which among these two, these three are related? T1 and T3 are the related to each other. Hence the second part. Now let me go for this one more example. Now one more example. Check whether relation R in R defined on the real number. This relation by such a way that relation set of ordered pair A comma B such that A is less than or equal to BQ. Such a way that the relation defined is reflexive, symmetric or transitive. We have to verify that one. We have to check that one. Now be careful. They are defined on the real number, not on the natural whole like that. If a natural number or whole number means it is easy to verify, but they given on the basis of the real number they define. Okay. Now I will take one of the example. What is that one? Whether 1 by 2 comma 1 by 2 is it in the R, we have to check. 1 by 2 is an A, again 1 by 2. It means what is the reflexive first of all? Reflexive nothing but if A comma A is written belongs to R relation means for all A belongs to real number means then we can say that this is reflexive. Okay na? Then whether it is reflexive or not we have to check. Whether A comma A is belongs to this relation or not we have to check. For that purpose I will take one of the example, that is an 1 by 2 comma 1 by 2. Is it in an R? We have to check. Now according to the definition 1 by 2, what is an according? 1 by 2 is it a less than 1 by 2 whole cube? Is it less than 1 by 2 is less than or equal to 1 by 8? Is it right? No. What is it equal? 0.5 it will come. It is an what will come? 0.1 some 1 comma 2 it will come. It means that 0.5 is greater than 0.12. It's nothing but this is not a condition is satisfying. Hence what we can say 1 by 2 comma 1 by 2 is not in the R. Is it not in the R? It is not in the R means R is not reflexive. R is not reflexive. Next, second one. I want to verify whether it is reflexive or not. Let me take one of the order pair. 1 comma 2. 1 comma 2 is it in the R? I took it such a way that one of the ordered pair I should take that must be belongs to R. It is belong to R. Let me check it. 1 is it a less than or equal to 2 cube? A is less than or equal to S. 1 is less than to 8. 1 is less than 8. S. It is in the R. What I took an ordered pair, that is the right. Now, if it is an reverse, is it a 2 comma 1? Is it in the R? We have to verify. Okay, let me see. Now, according to definition, what is it? 2 is it a less than or equal to 1 cube? Is it a? No. 1 cube nothing but 1 only. 2 is never be a less than 1. It is a greater than. 2 is never be a less than or equal to 1. 2 is greater than 1. Hence what we can say? 2 comma 1 it is not in the R. 1 comma 2 is in the R, but 2 comma 1 is not in the R. What we can say? R is not symmetric relation. Not symmetric relation. Now we have to check one more, that is the what? I have to check this is a transitive or not. Let me take, if I will take a 2 ordered pair, 3 by 3 by 2. Is it in R? Such a way that I have to take 2 ordered pair I should take, that must be belongs to R. I took that 3 comma 3 by 2, is it in the R? Is it in the R? Is it satisfying that condition? Let me check it. 3 is less than or equal to 3 by 2 whole cube, I said that. Okay, now 3 is it a less than 3 by 2 nothing but how much it will come? 3 by 2 1.5 it will come. 1.5 nothing but 1.5 whole cube is nothing but 3.72 something it will come. You sure 3.7 is greater than 3? Yes. 3.72 is greater than 3 and 3 is less than 3.74. Hence what is the condition I took? That is right. Okay. Next one more ordered pair I will take. What is that one? 3 by 2 comma 6 by 5. I took this is in the relation. Is it a relation? Let me check it. No, I took that is in the relation. Let me check it. 3 by 2. Is it a less than or equal to 6 by 5 whole cube? 6 by 5 nothing but this is how much it will 1.5 it will come. How much? 5 1 is 5, 1.2 it will come. 1.2 whole cube nothing but 1.72 something it will come. Is it a 1.7 is it greater than 1.5? Yes. 1.5 is less than 1.7. Hence what I ordered pair I took in the relation is right. Okay, now 2 ordered pair I took. 3 comma 3 by 2 is it in the R? 3 by 2 comma 6 by 5 is it in the R because it is satisfying the condition. Is it then is it in belong 3 comma 6 by 5 is it in the R? Let me check. 3 comma 6 by 5 is it in the R? We have to verify. If it is in the R means then only it is a transitive, otherwise it is not a transitive. Now 3 is it a less than 6 by 5 whole cube? 3 is it a less than or equal to 6 by 5 1 by 2 1.7 it will come something 1.7 something it will come. Is it a 1.7? Is it in greater than 3? No, it is a less than 1.7 is a less than 3. Then that condition is not satisfied. Hence what we can say 3 comma 6 by 5 is not in the R relation. Then what we can conclude? Therefore R is not transitive. R is not transitive. R is not a reflexive. R is not a symmetric. R is not a transitive. We have verified this one. Okay. Now let me come to the next topic, that is nothing but types of functions. Mainly there is a two types of functions are there, which are those one-one function and onto function. One-one function is also called as an injective function and onto function also called as a surjective function. Let me see what is a one-one function. First one is a one-one. One-one is also called as an injective function. Injective function. What is an injective function? Otherwise, what is a one-one function? A function f from x to y. Function f from x to y is said to be onto. Sorry, 1-1. Said to be 1-1. Sorry. The function f from x to y is said to be 1-1. Images of distinct elements of x under f are distinct in what? What it means? I can't understand, sir. Okay, let me see. Images of distinct element of x. I will take a function f, that is an x and y. I will take a summary a, b, c, d. I will take a 1, 2, 3, 4, 5. F from x to y. Now image of a is 3, image of b is 5, image of c is 1, image of d is 4. Here there is a 4 element in the domain, there is a 5 element in the codomain. Okay, agree. Now all the element in the x are different image in the y. Different element. A as an image 3, B as an image 5, C as an image 1, D as an image 4. Different element of x or different image in y. A and B has the same image means that is not a 1-1. I am cross verification. Now different element in the x are different image in y. Let me say one more function, that is an g, that is from x to y. A, B, C, D. Here 1, 2, 3, 4, 5 is there. Now, okay. Now image of A and B is to both distinct element of same image. Distinct element of an x under f is distinct in y. Then only it is 1-1. But distinct element of x is same in y. It nothing but an image of an A and B is same. Hence it is not an 1-1. This is an many one function. This is an 1-1 or injective function. What is once again? A function f from x to y is said to be 1 1 or injective. Image of distinct element of x under f are distinct in y. Distinct element of x or distinct image in y. Then it is called 1 1. If distinct element of same image in y, then it is called the many one function. Be remember. And also, how can we define in a mathematical way? It is a 1 1 or not. What we said? For all x1 comma x2 is it in the domain such that I will take f of x1 is equal to f of x2. What I said? Two elements I took in the domain such that their images are same. Their images are same means their pre-images x1 is equal to x2. It implies x1 is equal to x2. Then only it is a 1 1. What I said? If their images are same means their pre-images also same in the domain. Okay. Otherwise, one more type we can define. If x1 comma x2 is it in the domain such that if f of x1 is not equal to f of x2 means their images are not equal means we can say in another way x1 also not equal to x2. If their images are not equal in the y means their pre-images also not equal in the x. This is a mathematical way to define the 1 1 function. While whether given function are 1 or not, we have to verify in such a way that we should verify. I will take two elements in the domain. I will take their codomains their images are equal. If their images are equal means their pre-images also equal. If we verify this relation means we can conclude that is a 1 1. In another way we can conclude that I will take two elements in the domain such a way that I will take these images are not equal. Images are not equal means we have to verify their pre-images also not equal. Then only we can say that is a 1 1 function. Okay, understood? Now one more, that is nothing but onto. Next is a onto function. Onto function is also called as an what? Surjective function. Surjective function. Okay, what is a surjective function? A function f from x to y. Function f from x to y is said to be surjective or onto function. Every element of y, domain, every element of y, there is an image in x under f. Here some wrong is there. Here every element of y is the image for some element of x. Some element of x under f. Be careful. Every element of every element of y in the domain is the image. It must be image for the some element of an x under f. It must be all the element of y must be images for some element of an x. Let me check. Function f from x to y. Okay, I will A, B, C, D, 1, 2, 3, 4. Okay, now f from x to y. Here one is the image for A, 2 is the image for B, 3 is the image for C and D. Every element of Y is the image of some element of an X. It means that there is no free element in the codomain. All the elements, every element must be an image for the some element. There is no free element. If it is a free element, then A, B, C, D. 1, 2, 3, 4, 5. Here all the element of Y is not an image for some element of an X. Here there is an element 4 is a free. It is not an image for any element of an X. It is not an image means one of the element is free in the Y. It is in the free in the Y means then it is not an onto. According to onto what? Every element of Y is the image for some element of X under F. But here according to definition it is not an satisfying. 4 is not an image for some element. Okay, now 4 is not an image means one of the element is free. One of the element is free means it is not an onto function. But look at the function F. Here all the element of Y is the image of some element of an X. 1 is the image for A, 2 is the image for B, 3 is the image for C and D. It may be a 1, 1 or not, we don't bother, but there is no free element in the codomain. Now, according to definition of according to definition of an onto or subjective, one conclusion we can give, one more conclusion. What is that one means? There is no free element, means all the element of codomains are images. Then what is the set of images? Set of images are also called what? Range. Also called range. It means that all the elements are the images. Then the set of codomain. The codomain is the range in the onto function. It's nothing but all the elements are images means all the elements are images means all the elements are images means that is nothing but a set of images. Set of images nothing but that is a range. Then in onto function codomains is range. Is because all the elements of Y are the images. The set of images is called range.